All right. We've been talking a lot about parallel lines, uh, alternate interior, alternate exterior, consecutive interior, all that stuff. Good. So now we're going to go through and prove each of these theorems. And there are a couple proof ideas that you need to understand, which is really the reason we're doing this assignment. The proofs are simple. They're all really easy. Yes. What's that? We're teaching you logic. Yeah. Okay. So if you look at the front page on your worksheet, so let's review the relationships really quickly. What would you call angle 1 and angle 5? Corresponding angles. And corresponding angles are congruent when the lines are parallel, right? Okay, what would we call angle 1 and angle 8? Alternate exterior, and they are congruent as long as the lines are parallel. Right? What about 3 and 7? Consecutive interior, and they are supplementary as long as the lines are parallel. And then the last one would be 2 and 7, alternate interior, and they are congruent as long as the lines are parallel. So all four of these rules are, they hinge upon the lines being parallel. If the lines are not parallel, then the rules are not true. Okay? So we want to prove that alternate interior angles are congruent. We could have picked any one of them. I just picked alternate interior. So let's prove that angle 2 equals angle 7, and the only thing that we're given is that the lines are parallel. That's all the information we know. And we make proofs really general. We don't know how big angle 2 is. It could be acute, it could be obtuse, it could be right. It appears obtuse in the picture, but that doesn't mean anything. Okay? If it's unlabeled, it could be any size, which is good. If we can prove that an unknown angle is the same size as another unknown angle, that means that alternate interior angles are always congruent for all possible sizes. So if I prove 2 and 7, then automatically 3 and 5 are also congruent. If I were to draw another shape that didn't look a lot like that one, I can guarantee that those two angles are congruent, even though they appear acute and the other appears obtuse. Does that make sense? So we prove things generally so that we have specific cases in the future. So how would we do it? How do I know that 2 and 7 are the same size? Okay, so they are alternate interior, and we've already said that they're congruent, but we want to prove that that's always the case. The only thing we're assuming is that the lines are parallel. But Bridler brings up a good point. What if I knew that alternate exterior were congruent? What if I knew that 4 equaled 6? Would that help? Yeah, if 4 and 6 were the same, and 4 is vertical to 2 and 6 is vertical to 7, then 4 equals 2 and 6 equals 7 and 6 equals 4, therefore 2 and 7 would be the same. But I don't know that alternate exterior angles are congruent. So I can't use the alternate interior rule because that's what I'm trying to prove. I can't use the alternate exterior rule because that has not been proven. What's left? So I could say that using consecutive interior angles, 2 and 5 are supplementary, and 5 and 7 are supplementary, therefore 2 and 7 must be congruent. But do I know that this is true? No. So that's out. What about corresponding? Well, what if I told you that angle 4 and angle 7 are congruent, Well, 4 and 2 are vertical, so if 4 equals 7 and 4 equals 2, then 2 and 7 would be congruent. But do I know that corresponding angles are congruent? No, I can't assume that. Well, we're out of options. Okay? All 4 of these ideas go together. If one of them is true, then all of them are true. Okay? Right. It's one of them is unprovable. Any one by itself is totally unprovable. Why is that? Well, let's look. Let's assume that consecutive interior are supplementary. Okay? So if consecutive interior angles add up to 180, then the lines are parallel, correct? All right. Well, there's my sphere. Here's my equator. These are right angles, right? So consecutive interior angles add up to 180. Are the lines parallel? No. Okay, so we don't want to assume anything, because once we make an assumption, then that's going to change the mathematics that follows. If you remember back to Euclid, and I know I've drawn this picture a whole bunch of times, Euclid was proving the Pythagorean theorem. And after about half of his book, he wrote a postulate that said, if you take a line and a point not on the line, there is exactly one line through that point that's parallel to the given line. As soon as he used, this was called the fifth postulate, as soon as he used that, he destroyed the sphere. He also destroyed the hyperbolic plane. So that's gone. He didn't know. That's the thing, he didn't know about the hyperbolic plane. In fact, it was not found, basically, discovered for another 900 years. It's true on a flat surface, yes. But Euclid understood math, and he tried as hard as he could not to put it in, even though he didn't know why. I don't think he understood spherical geometry at all. But he understood proof, and he said, I'm not going to use a postulate unless I absolutely have to. And in the end, he realized there was no way around it, so he used it. And I seriously doubt he knew the effect that that had. So he might have known about sphere, but I've never read or heard anything about that. He certainly didn't know about the hyperbolic plane. It simply didn't exist for a long time after that. So we said that the fifth postulate is exactly the same thing as an angle sum of a triangle equaling 180 degrees. So if you state the fifth postulate and I state that triangles have an angle sum of 180, those are equivalent statements. They do exactly the same thing. They limit your geometry to the flat surface. Well, in order to do this proof, in order to do this proof, we have to accept one of these 4 rules as true. And as soon as we accept it to be true, then we're going to do exactly what the fifth postulate said. Okay? On the other side, on the hyperbolic side, we could have lines that look like this. And this angle might be 100 degrees. And this angle might be 90 degrees. And the lines are still parallel. Does that make sense? So in the hyperbolic plane, alternate interior angles do not need to be the same in order to be parallel. So by accepting any one of these 4, we will restrict ourselves to the flat surface, which is what we're going to stick with, I think, the rest of the geometry stuff that we study in here. So it doesn't matter which one we accept. For some reason, we always pick corresponding angles. So this is exactly the same thing as the corresponding angle postulate. And once we know that one of them is true, then the other 3 are very easy to prove. And that's what we're going to do today. We're going to prove The other three, and then one other thing. I've given you an example, a definition of the corresponding angle postulate. So when two parallel lines are met by a transversal, corresponding angles are congruent. So angles in the same position. So 1 equals 5, 4 equals 7, and so on. So the corresponding angle postulate relies on the fact that the lines are parallel. So if you tell me that the lines are parallel, I can then state that corresponding angles are congruent. So now let's do the proof. We want to prove that angle 2 equals angle 7, alternate interior. What should I start with? Hold on, before I can use corresponding, I need to state the lines are parallel, right? So my first statement is going to be line AB is congruent, nope, not congruent, parallel. So AB is parallel to line CD. How do I know that's true? That was given. Okay. Now I'm able to state that angle 4 is congruent to angle 7. How do I know that's true? Corresponding angles. Remember when we did the pizza logic thing a couple weeks ago? And when you were ordering a pizza, it had to be in a specific order. Could I flip the first and second statement in this case? No. In order to use corresponding, we have to list that the lines are parallel. Otherwise, this is untrue. That statement is only true if the lines are parallel. Okay? How does that help? So we've now said that 7 and 4 are congruent. What's that? What did you say, Braden? Well, 4 and 2 are congruent. How come? Does their vertical angles, does that rely on parallel lines? So angle 4 is congruent to angle 2. Would it be incorrect to move this to the top? Yeah, so that's totally fine. Vertical angles do not depend on parallel lines. So really, I could put this wherever I wanted. Putting it in the middle doesn't make much sense. But if you stated that first, you would be okay. A lot of people like to start with the given, but that one has flexibility. It doesn't matter where you state it. As long as it's stated, we can use it later. Okay? What else? Oh, this is true because they're vertical angles. Now what? Can we jump straight to the end? Angle 2 is congruent to angle 7? Yeah, we have everything we need. So angle 2 is congruent to angle 7. What's the reasoning? Well, they are alternate interior, but we can't use that as our explanation. That's our, at the end, therefore, alternate interior angles are equal. You could use substitution. I would just write, the reasoning is, angle 2 is congruent to angle 4, which is congruent to angle 7. That's good enough for me. If 2 equals 4 and 4 equals 7, then 2 and 7 must be equal. Okay? All right, now, of the 4 items on the list, so we have alternate interior, alternate exterior, corresponding, and consecutive interior. We accepted consecutive nope, that's not the one we accepted. We accepted corresponding to be true as a postulate. It was unprovable, so we just said, yes, it works. And by doing so, we threw out 2/3 of all geometry, and we just narrowed it down to the plane. And we've now proven alternate interior. On the next proof, you are asked to prove that consecutive interior angles are supplementary. So we're going to prove this one. I'm allowed to use alternate interior and corresponding. You might need both, you might need one. You certainly need one or the other. You can't get away with none. So let's, just so everybody does it the same way, let's prove that 2 plus 5 equals 180. So I'm going to let you guys work on that.